Hello all, my name is Podrouschek. I'm working here in Beckhoff Automation in product management of I/O, and today we will make here a webinar about Beckhoff I/O analog products. You see here some links for further information and this landing page for all questions about analog issues and product pages. This webinar is first webinar of two, and we'll cover now part 1 and 2, selection of analog modules, and a short quick start of these modules in EtherCAT 3.1. And in a following webinar, we will then see about configuring such modules and having the data in EtherCAT scope. This webinar, this analog webinar, is also triggered by the show last year in 2016 of this high precision ELM module series for EtherCAT. And so to answer these coming up questions, we will do a lot of some documentations and hold such kind of webinars. Focus today is analog hardware, analog devices of Beckhoff. And we will understand it better when we see the complete system of the Beckhoff EtherCAT controlling world, which is a big software part and a big hardware part. In the software part in EtherCAT 3 and all other software that can run on every normal Windows PC, there we have a lot of specific analog and measurement things. In TC measurement we have the scope integrated, body plot for drives, the analytics functions, and the new filter designer that is very usable to create filters for yourself in software. Also here in the software area is our MATLAB and database and HMI, so all of visualization functions running. In the real-time environment on the IPC, which is realized by the EtherCAT real-time software on every standard IPC, we have the motion functions, NC, CNC calculating for the axis, and of course PLC, C++ coding for real-time code. Real-time in Beckhoff means that we are talking about cyclic work of tasks. Our tasks are always working in a defined cycle time, for example 10 milliseconds or 1 millisecond, but we also have a lot of customers that are working with 100 or 50 microsecond cycle time solutions. So you can really run here from a standard IPC with EtherCAT 50 microsecond cycle time with hard real time on a standard IPC. Time synchronization is a big issue in automated applications and in test stands and in laboratory, because our system and the devices can very easy be synchronized against an external clock. MATLAB and database functions also in the real-time environment are necessary when you want to calculate PLC data with a MATLAB function, for example. Now we will go down to the hardware, and the transition there are some special software functions. The energy library and the condition monitoring library are special software packages which are specially programmed to cover special requirements from this hardware side. So the analog part of the Beckhoff hardware, there we have special technical parts. We have the new precision series of the ELM3 series. Since 25 years we have the standard analog inputs in EL and in K-bus area. We have special energy measurement modules, which from our side also is integrated in the analog area. We have condition monitoring modules and special time synchronization modules. Safety, analog safety is also an issue in Beckhoff, because more and more machines have to cover safety regulations against human hurt. And so some safety functions must be integrated into analog measurement modules. Yeah, and this all together gives then the scientific automation application of Beckhoff that we can cover and offer with our lot of analog modules. To understand such an analog value more, we have to understand that every analog value is living in two dimensions, a time dimension and a value dimension. Every value has a point of time where he is sampled, and for a good measurement world it's important that the uncertainty of time is very low of the data. In EtherCAT this is very well fixed with distributed clocks, because the slaves from slave to slave and from slave to master to the IPC, there is a distributed clock function, the synchronization technology available, and this gives the slaves the ability to run in time up to a jitter lower than 100 nanoseconds in input and in output area. And the other point is the uncertainty of the value itself. That is done by good developed analog products with a good calibration to have there a very low error of the value itself. Now we have some hundreds of analog devices in our catalog on our website. In the following steps I will give you a guide through these products, and in the end there should be a selection of one product at least that covers then the requirement of the task. The first question to select such a device should be, which interface do I need? Have I to measure 10 volt or 20 milliamp, potentiometer, PT100, whatever? And this is the first question. The next point is where I have to mount my modules. Have I to go into a control cabinet in IP20, which is necessary for the normal EtherCAT EL modules or K-bus or the new ELM series for measurement, or you can see here on the right side the EG modules, a very special housing format for high volume numbers of devices. And the other point can be Beckhoff products are also available in IP67 when you have to mount the analog device, the analog input or output device directly on the structure of your application of your machine. Next question is, which field bus should be covered? We have a modular system in IP20 and in IP67, and it can be connected with very different field buses that are covered by Beckhoff. EtherCAT itself, invented by Beckhoff, is the technology that we use in the latest measurement devices, but with special couplers. These EtherCAT terminals can also connect it to another field bus to talk then analog data to other controllers, masters, independently from the communication system that is used inside of the I/O modules. Analog, from the analog side, there are three questions about sampling rate and signal bandwidth. So you have to select from our devices if you need a very low sampling device or you need many samples per second. We offer devices up to 100,000 samples per second at the moment. And following question of this can be if these analog inputs must be working simultan, so at the same time, or it should be multiplexed devices. Then from the solution, from the application, comes the requirement about the accuracy. How big is the measurement error allowed? And there we have very different terminals, from very rough measurement error, 3% full scale value, up to very precise one. And the signal bandwidth, that means what is the signal you want to see. In all of our analog input devices we have hardware-based anti-aliasing filter, and sometimes you can change it, but in the most devices it is a fixed filter and it is then designed for the sampling rate of the device. Timing features can be also a requirement of to an analog input. Beckhoff has the family of XFC terminals, extreme fast control. That means these are devices, terminals, analog devices that are specially designed for very fast sampling and very fast reaction. They're always working with distributed clock as time base for simultaneous operation, and some of them are working with a timestamp and others are working with an oversampling, a very important feature, so I will explain it here on the right side. Oversampling means that in our world the TwinCAT, the task, the program is always running in a hard fixed cycle time. As I said, for example, 1 millisecond cycle time, the complete program should be run in one completely. When you have big programs, you can make more tasks. You can make a 100 millisecond task in addition to a very fast task and a super speed task. So you can combine different cycle times on one IPC, and such a task will then trigger the field bus and gather the analog data. And the black arrows here are the control and communication cycle, for example 1 millisecond. And the red arrows here is the oversampling. That means that the analog input terminals are running n times faster than the cycle time, and so much more analog values can be sampled than just with the control and communication cycle. And that gives you the possibility to run with a low task and low cycle time, but to have the analog inputs with a very short time resolution. And the last requirement that from the application side can come is what general features are needed in my machine, in my test stand, in my test bench. Do I need some special filters which are available only in some special modules, or do I need a module which is changeable in hardware from voltage to current measurement, or maybe I need a calibration certificate on a terminal. So this can be another requirement. So, and when you have these requirements on a paper, then you can select from the catalog, from the website, which product is really needed for your site. A short overview over the over 100 modules, analog modules, classes, families that we have on our website is here given. You see the family names EL3xxx. The XX means there are some other figures that you can find in our website to define a product more better. And here in the first family, in the first green family, you find all our standard industrial interface devices from a very low resolution, 12-bit over the standard 16-bit, up to the high resolution 24-bit. And you see the typical overall error that stands for these classes of devices. It begins with very low 0.3 full scale value up to high precision modules. An important point here, high resolution not automatically means that this is a precise terminal. When you use electric with a high resolution, it's easier to achieve a very high accuracy in the module, but high resolution not automatically brings you a very precise module with a very low error. You see here in the Beckhoff modules, we do only combine high resolution with a very low error because this makes only sense. But the big question is not only what is the resolution, it should always be what is the measurement error that you can really reach. Next point is the sampling rate. You see we have very slow terminals from 1 milliseconds or slower up to our fastest devices, 100,000 samples per second. Let's come to the next family here, EL3xxx for strain gauge. In the new ELM series we have also full, quarter and half bridge supported up to 20,000 samples per second in 24-bit resolution. You see here on the red flags which of these terminals support oversampling. I explained before, we think that this is a real important feature to have very high amount of analog data. Big data can be one sentence here, to get this data and to have then the calculation in TwinCAT on the IPC side. For temperature measurement, RTD and thermocouples, we have a lot of devices. Here are listed the devices with the very high accuracy. And then in the next family we have here our power measurement modules for 230 volts up to 690. On these terminals you can measure voltage and current in 3 phases to the same time. These terminals are very good, or they are very good to use when you want to make a clear detection of the zero crossing, or to measure any values of power that is used by your machine. A very special terminal here is the EL3xxx. It measures just resistance with a very high resolution. It shows you that we implement also very special functions into our standard automation products, to cover all needs that we have in our industrial automation area. Condition monitoring is a big point to connect any condition monitoring sensors over the IAPE signal. And so we have there in EL the 16-bit and in ELM the 24-bit resolution with 50,000 samples per second. And here the last line on this page is our multifunction family. We have some terminals that can cover all other interfaces that I have listed before, but not the high voltage interface. These are nice devices sorry, to use them in a laboratory environment when you have to change between the interfaces every hour. And some other special terminals that we have just here in the EtherCAT area, some pressure measure modules where you can connect the air directly, potentiometer measuring, and as I said before, safety is integrated in the analog modules in the 0090 series. And a very special requirement can be the galvanic isolation. So when between channels, galvanic isolation between analog channels, and for this requirement we have here this special device from the EL31 family. This overview is here especially for the EtherCAT analog input terminals. We have also the K-bus terminals, which are from mid of the 90s invented, and also in these terminals we have some high precision measurement modules, the KL3 modules, but since the K-bus communication is not so fast as the EtherCAT communication, you can with the K-bus terminals not reach that powerful functions that you can reach here with the EtherCAT terminals. And both families, the EtherCAT and the K-bus terminals, are also available in IP67. So not all of them, but some of them are then transported in the other housing when you have to do your solution in IP67. And because we have shown here last year in 2016 this ELM high precision family, I will have here now a special focus on that one. This family, they have all very specific characteristic with 24-bit resolution, high accuracy, and 10 to 50,000 samples per second. And a big part of these devices is the internal diagnostic, because we think that these modules are used in machines. The machines are running for years and nobody cares about that, and so these modules have to do wire break and so things for themselves in a very big deep to prove that their analog data that they measure are of a very good reliability. In this family we have here 11 devices now. from multifunctional on the left side, you see it, and then the simple devices, the voltage measurement from 20 millivolt up to 30 volt, current measurement 20 milliamp area, and the strain gauge measuring bridge device, also as the others in 4 and in 2 channel housing. And last one here, the IAPE variants that in the 2 channel housing can run up to 50,000 samples per second. Now we have a lot of talked about analog inputs, but into the Beckhoff analog world, of course, analog outputs also are important. So in the K-bus and in the EtherCAT area, we have their 12 and 16-bit solutions, devices here. These are the IP20 devices. Also here, IP67 is available. And you see here, these both modules for 732, for example, they also support oversampling. The same what I said before with oversampling measuring, you can do also with the outputs. Now we have an overview over our devices, but now you have to select the right one for your solution. And there now I will call your attention here to this some specification extensions that we do in our analog documentations. Please read them to understand our specification, because everybody like Beckhoff are doing a lot of in specification, but it's always important to understand the value that is printed there. And so we have there some chapters in the documentation to explain that. One here is the what means Beckhoff with full-scale value, what is the Beckhoff definition of full-scale value to understand our own specification. We have a chapter about our Beckhoff measuring error. In the most terminals we give the complete measuring error of overall temperature, overaging, overall. We think that this is a good way to give the worst case scenario to the customer. What is that what he has to calculate with? And in the last times we extend our documentation to further detailed specifications also. Like this one, like the temperature coefficient, when it's defined by the specification how you have to calculate with. Another point is single-ended and differential difference. Most of our terminals you can have in single-ended or in a differential version, because this is often very useful in an automated area to have lower wiring costs, and so the internal difference are here explained. Common mode voltage and reference ground is also here an own chapter. Okay, now we have the theoretical part, and I hope with these hints you can select from the Beckhoff website, from the catalog, the module that fits into your requirement. And now in the second part of this webinar, I will show you in some minutes how to get such an analog device running on TwinCAT 3. So let's say you have now the modules, the one module selected that you want to have, and you have it on your desk. What do you need to make it running? And you can follow this webinar, for example. Here on this picture, this is my demonstration set that I have here on the desk. It's just a C69 from Beckhoff, Windows 7 installed, TwinCAT 3 on it, so very simple. I use the system here locally also for this presentation at the moment. So the office is here installed because here it's for me simpler to have it as a local machine. Of course, I can do a remote programming to connect TwinCAT to another IPC, but here in this demonstration we do now a local work on this system. And you see here one coupler and some analog input terminals, power terminal that generates 12 volt, and the last terminal here is strain gauge input device, and you see here the strain gauge laying on the desk. Okay, and now in the next minutes we will open TwinCAT and see that we get it running here like it is shown on this, and in the end we will see then the analog input having here in our system. So for this reason, I will here open now my desktop and open now Visual Studio. How to get this EtherCAT Visual Studio integrated? It's very easy. You can go here to the Beckhoff website, go to Beckhoff.com, download, and you see here in the EtherCAT III area, you can download here this TE1 Engineering, 200 megabyte. It's very easy, and install it on your IPC. And when you have no Microsoft Visual Studio, it's no problem. There is a shell coming included here in the setup, so in the end you will find such an overview. Okay, so now we will open a new EtherCAT project. You can do it in here on this point, but now we do the very formal way. We make new project. We will select here a EtherCAT project, a standard project. We can see where it is stored to, and the name here on this point is not important. And now we open here a new empty EtherCAT III project. So here we are. Now in this webinar we have the focus on the IOs, so we will just have a short view. You see here the general system issues, motion, access control, it's not point now. PLC, we will just add a small PLC in the next minutes. Safety and C++ is no issue now. And now let's check for the IOs. I will restart here my system in config mode. You have to understand that EtherCAT can have two states. The machine can run, or it can be in some idle mode. The config mode that you see here on the blue icon or here is the idle mode, where no real time is running. And in this mode I can do a scan. He says, oh, he cannot find everything, but the EtherCAT devices that I will present here, he can find. Then he has found here the EtherCAT device on the Ethernet port, and I say him, yes, please scan for the boxes, and then he will automatically generate the configuration. Now I make free run. Yes, free run means that in the idle mode now idle task is running and just gathering the input and output data, and you see here the short station in the order that I have connected here. As an example, you can connect up to 65,000 devices here, and you can connect more field buses, other systems, all of them, for example, Profibus devices or Profinet masters. You can also connect by USB, whatever here, other devices. But now we will make this EtherCAT presentation here, and we will check if this EtherCAT is running, and we see, okay, the most slaves are in operation installed, this is good. And we see here that we have 500 frames per second is running. This is the idle task. And just for control, we will double click on the terminals here. You see the channels are opened on this side, and you see the variables, the input variables are running, something is living here on this side. So I would say after 1 minute we have here a simple analog system running. But now let's do the last step to the real-time system. I will now integrate here additional PLC task. It is a standard PLC project. We will call it now project 42, for example. Now an empty PLC project is here integrated. You can add several projects. You can add different tasks, different cycle times. So you can make everything that you can run on a 64-core, multi-core, multi-terabyte working space IPC. So we will see here now and find a very simple project. There is just one main program. We will open that. And just to have something to see, I will add a counter here. And because I want to read the analog input of the analog terminal, I will have a view here on this side. I want to connect to this sample. This sample is a 4-byte device. When I do not know what I have to connect to, for example, you can use the Beckhoff information system. Beckhoff information system is online available on the website. I will just show it to you. You will see it here on the right side here. Here is the link, Beckhoff information system, infosys.beckhoff.com. But you can also install an offline version, as I have here done, and I think the int is the right one for me to connect. And now I find here the entry, the int, yeah, it seems to be the right one for the 32-bit. So I will define it here on that side. In EL3xxx input, for example, and to say TwinCAT that I have it to use as a linked variable, I have to specify this letters. And now let's just make some very simple code. +1, so just a counter, very simple. Now I want to build my very senseless program. So everything is okay, but I have not connected my fieldbus. To understand the Beckhoff world, the TwinCAT world, you have a field system outside here, you have different hardware outside, and it always have to run, to be triggered, to run synchron to some tasks. And to do that, it's very simple. We just say that this terminal, the sample, and I do a double click, and then it opened here the variable that I have defined here in the main, and I connect it, and then you see a small error, and then you have a mapping between the IOs on this side and the PLC on this side. And that's all, just to say him, give me this value here into the main. And so then I can also do a build solution. He will do a lot of calculate, so everything okay, no error. And then we do the magic buttons. So from the left side, we do activate the configuration. That means some very special values are written. We see here a hint about virtual machines. And then now when you have installed TwinCAT fresh on your system, you will get this message because you have maybe no license paid for. And TwinCAT can be used for 7 days without pay a license. I will do yes here and just give these numbers here. And then everything is okay. And my license are now ready for the next 7 days. And after 7 days, you can repeat it. Now we can restart the TwinCAT system in run mode. Now you will see that the buttons will become green. Now this local TwinCAT machine, the real time is running with the cycle time of this main program that we will see here on the PLC task. At the moment we will run default by 10 milliseconds. It's just for demonstration. And now I have to make my program running because this program is not sent down. I will now do this both windows side by side so I can see more. Here we will see the EtherCAT running, and on this side now I will, with this button, I will make a login. I will send down my program into the real time, and then with this button I start the machine. And now you see the counter is running, and the input is running here. Live value, you see it here. Now I can, with different functions and blocks, I can calculate and make filters and also, but this is not focus of this webinar. And on the fieldbus side, you see all slaves are now in a good state. Operational is the final state that a slave should have, so this is okay. I can send the complete fieldbus into different states. Save up into operational, so everything is working. I see here 100 frames per second, everything is in a normal state. And just to check my device itself, when I click here to the terminal, I see the analog value is running here without oversampling. Oversampling factor is here 1, so we have only one sample. We see here a timestamp. We see the working counter, which always should be 0. We see the input toggling. These are the diagnosis variables. This is toggling very fast with every new value. And we see the state 8 means operational. Everything is okay. So very simple to get analog input devices and all other modules IP20, IP67 of the Beckhoff area running here in EtherCAT 3. Yeah, this was this part of the webinar. Next webinar will be about how to configure such analog module and to make this analog data then viewable in EtherCAT scope. Then thanks for your attention and up to the next webinar.